Welcome to the fourth and final part of our course dealing with integration between Tekla Structures and Tekla Structural Designer. Within this section we will be providing information dealing with advanced examples, prior to a full demonstration of the integration process in both directions. Starting off with the advanced information, please be aware that we can transfer FabSec sections, plate girders and Weststock plate girders between Tekla Structures and Tekla Structural Designer. The import into Tekla Structures will automatically map the parts and build a section using the HI profile shape. This is done behind the scenes with the user not being exposed to the mapping details. Any holes and stiffeners will also be imported into Tekla Structures, but not exported from the Tekla Structures software. To ensure that openings are not deleted as part of the merge process within Tekla Structural Designer, remove the option to update openings shown in the Structural BIM import wizard. This will keep any openings within Tekla Structural Designer unaffected. Steel joists are transferred between Tekla Structural Designer and Tekla Structures without any issue, and can be round-tripped without any problems being encountered. Please note however that Tekla Structures uses an alternative physical representation for the joist than Tekla Structural Designer. For wall elements, we can confirm that shear walls modeled in Tekla Structures will be transferred to Tekla Structural Designer provided the correct settings are used. The wall element should be created as a panel element, defined from the start to finish location. The name assigned must be designated as shear wall. The shape should be stipulated as being a height by thickness reference. For multi-material modeling, there are generally no problems with multi-material models. Both Tekla Structures and Tekla Structural Designer are capable of handling steel, concrete and timber elements. If any mapping problems occur, create CNV files to bypass any issues. As long as any mapping problems are corrected, then there will be no issue with the overall transfer. The final stage of the process is to perform a demonstration of the full import and export process. The model will be passed in both directions. We will demonstrate changes being made and alterations to the model being tracked in both software packages. This is our model which we will be integrating with Tekla Structures. As you can see, the model is already designed so as at the stage where it can be integrated. You can see that the model consists of mainly steelwork with beams, columns, bracing and trusses being defined along with some concrete slab panels as well. We orbit the model so that you can visually see the shape of the building, and we can also view the construction levels dialog so that the entries within there can be noted. There are a total of 5 levels defined with all but the uppermost being flagged as floor levels. Therefore the top level, which incidentally has not been named, will not be communicated through to Tekla Structures. As we are ready to perform the export of the model to Tekla Structures, we pan across to the command held on the Home tab, Tekla Structures Export. Clicking on this launches the wizard process to generate an export file. We read the information held within the product splash screen, and then click on Next to proceed further. There is no need to relocate the model to real-world coordinates as defined within Tekla Structures. We keep all of the data held in the relocate dialog at 0 and just continue onwards. On the integration filter dialog, we choose to keep all of the preset items enabled so that the relevant content will be exported. We also check the analysis results option so that the end forces for beams and columns will be exported. When setting the analysis results to be exported, we will keep the default settings of first-order linear analysis, no load case results and all load combination results. We click Next to continue. As can be seen, there are no mapping problems for either materials or decking, so we can simply continue past these two screens. The final stage of the wizard is to set a suitable file name and location for the exported file. We choose to export to the desktop in this case and to call the file example T11, Stage 1. The export will be as a first-time export, as we do not have an existing Tekla Structures model to import changes into, and so we click Finish to complete the export process. The first integration file has now been created. We can check that this is the case by seeing that the Structural BIM export status entry is now ticked, and we can also swap the model to a review mode view, and check the BIM status command to check that everything has been exported. We are now ready to import our file into Tekla Structure. In Tekla Structures, we have already created a new model and have opened the default 3D view. We therefore start the import process by clicking on the File menu, Tekla Structural Designer button and finally Import From. When the import dialog appears, we click on the three-dot button and set the correct file name from the correct location. We can click on Preview Conversions and ensure that there are no conversion problems during the transfer process. If there were any, then we would have needed to create CNV format files, but in this case, there aren't any required. To complete the process, we click on the Import at Origin command, allow the file to process, read the import statistics, and finally close the import dialogs after the transfer has been completed. As the model view depth is not sufficient to view the entire model, we access the Properties dialog of the view, and increase the depth amounts to more suitable settings. We are now able to view the entire model. We can inquire on any of the beam parts, and check that all of the expected information has been correctly imported, such as profile size, material and section type. We can also perform an Inquire Part command on a column stanchion, and view all of the imported information for that member as well. By double-clicking on one of the grids, we can view the level coordinates that have been imported, and again check that these are correct to suit the model. We are now ready to make changes, and perhaps perform an update. Back in Tekla Structural Designer once again, this is our updated model. We dock the 3D view so we can view the model in greater clarity, but it can be seen that the main addition is the large concrete structure to the underside of the existing model. As we pan around the model, we can view the structure in detail. The concrete structure is a mixture of new concrete slabs, concrete beams, and column members, both rectangular and circular in shape. The model itself, though, has been designed and is in a suitable form to be exported. Checking the Construction Levels dialog, we can see the additional levels which have been defined within the model, and again, all but the uppermost level should be exported to Tekla Structures. We can click on one of the circular columns, and view the profile size and shape along with the assigned material. In a similar way, we can click on one of the rectangular columns and view the assigned profile shape and size. We are then almost ready to export the model to Tekla Structures once again. The final change is to alter the section sizes of the side bracing, so that this will be communicated through to Tekla Structures as a model change. We switch to a structural view, and then move to the right-hand view of the structure. With the view updated, we can use a crossing window selection around the area to be altered, and use the Properties drop-down menu to ensure that 6 bracing members are selected, 3 from each side of the building. We click on the section entry and set this to another size entirely. In this case, a 5-inch diameter tube member. We can now clear any remaining selections, return the view to a front top right viewpoint, and then export the model again to Tekla Structures. The procedure is virtually identical to the previous export that we performed. The only difference this time is that we increment the export file stage, so that we know the correct file to use in Tekla Structures, and that we also flag the export as an update to an existing model. We are now ready to import the second changed file into Tekla Structure. We are now back in Tekla Structures, and currently viewing the model that was previously imported. We can now import our updated CXL file by clicking on the File menu, Tekla Structural Designer button and the command Import From. As we are still in the same session of Tekla Structures, the previous import details are retained in the import dialog. We can easily correct this though by firstly setting the correct import file to be used. This will clear the previous statistics once the correct file has been set. We click on the Preview Conversions button to check that there are no conversion problems, and then finally click on the Import at Origin command at the bottom of the dialog. Once the file has processed, the model comparison tool will be shown indicating that we are performing an update to an existing model. The new tab indicates that 291 new parts will be created through the import process, and we can check through this information to see the data which will be imported. The Updated tab indicates that we have 6 bracing members which are being amended. Clicking on each entry, we can see that the section size is being updated, and we can keep the status for each item to being set to update. There are no deleted items, so the Deleted tab is empty, and although there are 285 unchanged members, we do not need to interrogate this data in any great detail. The model is therefore ready to be completed. We click on the Accept button, allow the model to import correctly, and then close the Import dialog down. We can now see the updated model. We can hover over any of the new or changed members to see the updated information visually. However, we can also use the TSD integration status representation to color code the model. Within the Properties dialog for the view, we can set the correct representation and then click on the Modify button. This colors the model to suit so that we can easily identify the dark green new members, which is the concrete structure. We can also easily see the light yellow bracing which has been updated, and the remaining structure colored magenta as it has been unaffected by the last update. We can orbit the model to view the coloring in a greater detail, but also reset the view representation back to standard when we have done, so that the model's original coloring can be seen once more. We've shown the updates from Tekla Structural Designer into Tekla Structures. Let's now make some changes in Tekla Structures, and feed these through into Tekla Structural Designer. Double-clicking on one of the eaves members allows us to access the Properties dialog, and to change the profile to an 8-inch rectangular hollow section. By keeping the dialog open, we can select the other 8 members in the roof, and similarly change the profile shape and size. We can delete a portion of the building by orbiting the model to suit, and then using a crossing window to select and remove a portion of the concrete structure. We can change one of the beam members in size, so that will also be communicated through to Tekla Structural Designer, and here we choose to increase the section profile. The final changes that we will make will be to delete the 3 stacks of circular columns and to replace these with rectangular concrete shapes, so that the BIM status coloring can be shown in Tekla Structural Designer. We use the Copy command here to perform the replacement. With our model now altered, we are ready to send these alterations through to Tekla Structural Designer. We'll launch the export process through the command and set the correct file name, incrementing this to now be Stage 3. We check that the conversion preview shows no problems, and finally use the Export Model command to generate the required CXL file. We now switch to Tekla Structural Designer for the final time. We are now back in Tekla Structural Designer, and viewing the model which was exported to Tekla Structures. We can start the import process from Tekla Structures by clicking on the Structural BIM Import command, which is held on the Home tab. Within the wizard, we firstly select the correct file to be imported, which in this case is our Stage 3 CXL file. This in turn populates the remaining fields in this dialog of the wizard. From the file being read, the program has determined that the process will be an update to an existing model, and has set the unit system and head code to suit the correct settings. The default level type of top of steel relates to any new levels built externally, and as there aren't any, we can disregard this setting and move onwards. There is no relocation from real-world coordinates required, so we can skip the screen. On the integration filter, we will choose not to update slab profiles. Having made this change, we can move on through the wizard dialog. Finally, there are no problems with regards to the mapping of materials or decking, so we click on Finish and allow the merge procedure to complete. The merged model is now presented on screen, and we can check both the status tree and the review mode to view the alterations which have been made. We firstly click on the BIM status command to color code the model, and this can now be seen on the screen. We can zoom in on particular areas, disabling options with the Scene Content command to help with view clarity, and here we can see that the eaves and apex sections are colored as yellow, indicating that they have been updated. The same is true with the beam, which was also externally altered in profile size. The concrete columns, which were circular, are now colored blue, indicating that these sections were deleted and imported from the structural BIM platform. Specific alterations can be seen using the structural BIM import tree, held in the status window. We can see that there are a number of items flagged as being deleted, with the original Tekla Structural Designer member reference listed. Further down in the list, you will see that there are entries for members which have been updated in section or grade. Expand this and again the specific details will be shown. Double-clicking on each entry will highlight the member in a structural 3D view, panning and zooming onto the member so it can be clearly seen. Double-clicking on the other references also pans to the member and selects it for further interrogation. When we have done, we can look at performing a validation of the model. We can zoom out to the model extents and then run the validate command, which is held on several tabs within the Tekla Structural Designer program. The validation in this case shows that the model is correct analytically, and further design or loading can now be applied. The entire integration process is now complete as far as this example is concerned. The models can be further altered, and changes can be communicated in either direction, but the process is exactly as has already been demonstrated. This brings us to a close on our training course for Tekla Structural Designer integration with Tekla Structures. We hope that you have found the information of use. If you have any further questions, please contact your local Tekla support office or reseller for further information. Thank you.